Hey guys, Mr. Bowman here. Today's learning objective is in white and we are learning to apply the parallel line angle rules. Before we get into these rules, we need to explain a couple of definitions. So the first one, well, what exactly are parallel lines? And another one, what is a bisecting line? So I'm going to look at a typical question. So a typical question would have a set of lines that are pretty much the same distance away from each other all the time. And then those lines are going to be cut in half by another line. So parallel lines, well, they are those two lines there. They are often denoted with a little line on each of them. And they are two lines that never ever touch each other. So if we carry it on forever, the distance apart here will be the distance they are apart here, which will be the distance they are apart there. So those lines are never going to touch each other. And on the flip side, or the other term we need to know, the bisecting line, well, that's actually a line that cuts through a set of parallel lines. And that line with the parallel lines results in a couple of interesting parallel line angle rules that we're going to learn about in this video. So I'm going to change pen color and we're going to list our three angle rules. So the first one we're going to chat about is corresponding. And I'm going to be changing pen colors quite a bit in this video. We're then going to move into co-interior. And finally, we're going to finish with alternate angles. And we're going to go through an example of each of these. We're going to try to state some geometric reasoning or a sentence that you'll be able to use to justify your answer. And I'm going to try and give you a few tips and tricks to differentiate between the two examples, which is often the most challenging part. Sorry, three examples, which is the most challenging part. So let's get into corresponding lines. So let's draw a set of parallel lines. So I've got a set of parallel lines here. And we've got a bisecting line. And I'm going to let you know that they're parallel by doing that line on each other. So corresponding angles, I'll draw an example. So for example, angle A and angle B. So those two are corresponding to each other. We'll change pen color again. So if we call this one angle B, it's corresponding one over here. We will change pen color again. So maybe we're looking at this angle down here. That can be angle A. Well, down the bottom there would be that version's corresponding angle. So hopefully we're seeing a pattern. And we'll finish up. So let's say maybe we called that one there angle A. Well, its corresponding angle would be over there. And the thing that we know about corresponding angles are corresponding angles are equal. So if you see a pair of corresponding angles, we know that those angles are identical. So if we clear some of our working, so let's say we know this angle here is 50 degrees, and we're trying to figure out what angle x is. We will be able to say that angle x is equal to 50 degrees, and that's because those two angles, they correspond to each other because they are corresponding angles. And I'm going to get into a few more ways to figure out how that example works in a little bit as well. But let's switch to co-interior angles. So let's draw another set of parallel lines. And I'm going to let you know that they're parallel by drawing a line on there. And then I'm going to draw a bisecting line as well. So I think co-interior angles are a lot easier to identify. So the way I remember them is co-interior. They are two angles that sit within the same room. And if you have a look at this diagram, that shaded area, well, that's a room. And I'm going to scribble in that area, that's another room there. So the two angles that sit within the room, so let's call that angle A and angle B. And we'll change pen color. and in the other room, angle A and angle B. For both of those diagrams, angle A and angle B, A plus B, they always add up to 180 degrees. So the geometric reasoning that we can use to support that is co-interior angles sum to 180 degrees. And by way of example, so let's get rid of our A's and B's here. If we know that this angle here, say, was 100 degrees, and we were trying to figure out angle Y, we would be able to say, well, we know Y plus 100 is meant to equal to 180 degrees. So we'll be able to conclusively say that Y is equal to 80 degrees. And that's because they're co-interior to each other. They sit within the same room. And the final one we're going to look at are alternate angles, and then we're going to go back and try to compare them to see how we can get them to each apply. So let's draw, there's another set of parallel lines. So we know they're the same by those marks, and we're going to draw a bisecting line. And alternate angles, they're a bit harder to spot. They are angles that sit within, I call them within the train track, but they are opposite each other in terms of those lines. So angle A there would be alternate to angle B there. And if we do it along the other side, angle A up there, well, that would be alternate to angle B down there. And the geometric reasoning or geometric feature about that is alternate angles. Alternate angles, they are equal to each other. So if we get into an example by clearing all our existing work, going a bit too far with the clearing there. If this angle here is, say, 105 degrees, and you're trying to figure out what angle X is, you would be able to say that X is equal to 105 degrees because they are alternate angles. So we very quickly run through what the corresponding angles are, what co-interior angles are, what alternate angles are. Let's quickly get into other features that will be able to assist you into figuring out which scenario applies. So the first one I think is obvious is, I'll change pen colors, let's change to pink. Co-interior angles and alternate angles, both of the angles sit within the train tracks. So that's a feature that we need to know. So both angles sit within the train tracks. And the same for the co-interior. So both angles sit within the train tracks. And again, so if you look at the corresponding ones, we can see that 50 degrees, well, that sits outside the train tracks. So in terms of corresponding, it is outside of the train tracks. So one in and one out of the train tracks. So straight away, if you see one in, one out, you should be looking at a corresponding angle. And I guess it's a bit more difficult. Well, how do you differentiate between alternate and co-interior angles? They both sit within the train tracks. Well, co-interior angles, if you have a look, they are on the same side. So those are both on the right-hand side of that bisecting line. Whereas alternate angles, you got one on the left and one on the right. So they're on alternate sides of the bisecting line. And so that's the other factor I use to distinguish between the two. So same side of the bisecting line. And here, they alternate angles. They're on different sides of the bisecting line. And that there's another feature. So hopefully that helps in distinguishing the two. And the last tricks that I want us to do is sometimes some people relate letters to them. So if you have a look at this one here, corresponding angles, if you have a look at that, that looks a little bit like an upside down F. If you have a look at co-interior angles, that there looks like a C. And if you have a look at alternate angles, that there looks like a Z. So some people use those letters to assist in distinguishing between the three parallel line angle rules. So that's going to wrap up our video. We went through lots of information and lots of different ways to distinguish between the types of parallel line rules. So we had corresponding angles, which were equal to each other. We had co-interior angles, which add up to 180 degrees, and we had alternate angles, which are equal to each other. So hopefully you found this video useful, guys.